My name's Darren Timms. I'm a principal at Daubney. I'm just going to show you a bit of a snapshot of some of the work we've been doing over the last number of years, particularly in relation to the way that we use technology in our practice and BIM. So what I'm going to cover is who we are and what led us to BIM, what are the benefits of BIM, how we actually work, so how we actually create what we do, the ARC and BIM, and the ARC is a building we've recently completed, so it's a bit of a case study, and just touch on some of the issues for the future that our industry really needs to grapple with. So who are we and what led us to BIM? We're a major architectural practice based predominantly in Sydney, but with also a small office in Brisbane, about 105 people in total, and we work in the commercial, retail, health and research and defence sectors of our industry. In about 2001 we took a step back from our CAD software, which we'd had for a number of years, and really thought that we weren't getting the best out of it. How did we know that? We knew that other industries were producing work like this. This is obviously the automotive industry, but we knew that the shipbuilding and other design industries, aircraft industries, were producing this kind of information. We knew that it was possible to take design and documentation from one model by virtual building, because our software vendor GRAPHISOFT were telling us that, but we really weren't doing that. We also wanted to reduce some of our risk. There's a lot of things that an architect does that are high risk, and it's usually the more, if you like, boring things that we have to do within our profession. What you see here in the background is a precast concrete schedule that's been automated from a model, and in the foreground we have a door and window schedule from the recent BER schools program. We wanted to be producing what we call bulletproof documentation, and there have been a number of studies in our industry about the standard of documentation and its decline over years. We knew also there was potential to reduce our risk and therefore increase our profitability in addition. This is an image taken from, it's a screenshot from our smartboard in our office. We use this in consultant meetings. This is actually taking a BCA consultant through the model into an existing building that we're adapting to help him to understand in the third dimension the fire compartmentation in this building. I spoke a bit before about the quality of documentation in our industry. This is a report that was commissioned in 2005 by an industry bodies in Queensland. It identified a number of problems in our industry in relation to documentation. There are lots and lots of problems. Just to reflect on a few of them. 60 to 90% of variations in our industry are due to poor design documentation, and that's estimated to cost our industry around $12 billion a year. The worrying thing from this report is that at the time CSIRO said that that standard was continuing to decline, and I've seen very little in our industry that said that that decline has halted or indeed has been reversed. Some of the root causes that the report identified: inadequate use of CAD. CAD really hasn't delivered, in my view, very much for our industry in the last 20 or so years. We really took on a piece of technology that simply replicated what we had been doing for hundreds of years, and that's drawing two-dimensional lines, in this case electronically as against on a piece of paper. There's also a direct correlation to a reduction in fees. I don't think that that's entirely about it being a competitive market, although obviously that is part of the problem. But also procurement methods have changed in the last 12 to 15 years, particularly the introduction of design and construct contracts, which probably 90% of our work falls under. So all that means that we need to get really smart about the way that we use technology, the way we collaborate and work together as an industry. This is a diagram that the CRC, a government-funded research body up until the end of December, and the Institute of Architects got together and collaborated on to produce really for our industry so that we could understand the different stages of BIM. At the bottom you'll see a bell curve with the word uptake on it. That's really where the Institute felt that the majority of our industry were working, very much in the intelligent 3D realm. We don't believe that that's true. We actually think that most of our industry are very much still working in 2D CAD. There is undoubtedly people pushing into the 3D realm and working in 3D, and there are also people doing great stuff with BIM as well. What I'm going to talk to you about is Liverpool Hospital predominantly, and also the ARC. Now, Liverpool Hospital started very much as a one-way translation. We were delivering models to other consultants. We are now getting models back, not from consultants in this case, but from subcontractors, D&C subcontractors. And I'm also going to talk about the ARC as a bit of a case study. The ARC's very much two-way translation of models. It was set up as a BIM project from the beginning, we managed to convince Investor to take that leap of faith back in about 2006, and we've now delivered on that with an as-built BIM, which I will show you. The dotted line really represents about as far as I believe you can go today, and that's really based around a couple of things. Model server technologies still have a little bit of work to do in our view, and also there are some legal and liability issues that our industry needs to grapple with, which again I'll touch on a little later. Just to give you an idea of Rice Daubney's journey with BIM, we purchased ArchiCAD in about 1995. We previously, before that, had a piece of CAD software called GDS. So we were very much working in a manual 2D realm and a 2D CAD realm right up until, as I said earlier, around 2001. At that point, we took our switch to 3D. We did a pilot project in 2001, and in 2002 mandated 3D for all our projects across the practice. And as you can see from the arrows on the bottom, we're now very much into the one-way and two-way translation of models. So we're now at a point in time, and I think our industry is at a point in time where 3D is quite mature. We're now very much moving into the realm of BIM, and that's really where we're heading, and that's what I want to show you today. So what are some of the benefits of BIM? We believe that you get very much better design from using BIM, and that's largely because we're making a lot of design decisions earlier. What you're seeing here is a cut through a project of ours. That section is through the same model, so it's just really being shown in different ways. It's being graphically presented at the bottom of the slide to show a client a visualization of the room, and in this case obviously a lecture theatre, and in the top of the slide it's graphically represented as a drawing that a builder can build off. But they are both from exactly the same model, cut in exactly the same place in that model. So you can see the level of detail that goes into these models, and that's really why we're getting better design. We're having to make a lot of design decisions much earlier in the process. We have better control and consistency over our QA processes, and therefore for us less risk. This is a shot or an extract of the model from Liverpool Hospital. The red walls that you can see in this model are fire compartment walls, and the green walls are acoustic walls. When this model is passed over to a subcontractor and he's running ductwork and pipework around the building, he knows that when he hits one of those red walls, he needs to think about fire dampers and fire collars, so it's very intuitive for him. Similarly, when this drawing is printed out in 2D, it's printed in colour, and those walls are represented in colour. So when someone's jackhammering a wall on site and looks at his drawing and sees that it's a red wall, he understands that he's now breaking through a fire compartment and he needs to address that issue. This is a snapshot from the arc looking down on top of the building, straight down the core of a 20-something story building, and you can see all the structure and architecture have been turned off. This is just the services. You can see how complex this is, and you can see how being able to work in 3D improves the coordination process for us, both pre-tender but also with subcontractors, and that's very important in terms of our collaboration on site. We believe we have better staff attraction and certainly better staff retention. Most kids today coming out of uni are being taught in 3D at uni. We're now starting to see the first generations of architects that have only ever known 3D. They want the latest iPhone, they want the latest DVD player, they want the latest piece of technology, and they are going to want to work with the latest technology, and that's certainly part of the reason that we work this way. We also believe that we're improving the construction knowledge of our staff. What you see here is a number of shots within a single model, but you can see when you strip down that model, there are studs being drawn, there are top hats being drawn, there are gaskets being drawn between glazing and cladding. There's a plan in the middle of that diagram, which is traditionally what a builder would have got. By our staff virtually building, they are starting to understand what they are asking builders to do on site, and they are certainly gaining better construction knowledge through the process. We're certainly getting better communication, not just with our clients. I think that's an obvious one from the point of view of visualizations. Again, this is a screenshot from our smartboard. These images get attached to minutes of consultant meetings. In this image, we're trying to convince a mechanical consultant that his ductwork can't go on the ceiling of this building. So he's working in 2D. We've modelled his major duct runs, which you can see in colour at the top in red and yellow and blue. And we're really working on the smart board live in our model to show him that he needs to be feeding his air through the floor and not in the ceiling void, because there is no ceiling void. He really couldn't grasp that from a two-dimensional perspective. We believe also that we're getting improved productivity from the way that we're working, and hence, for us, improved profitability. At the end of the day, we are a business and we need to show a return on the work that we do and the commitment that we make to technology. So how do we actually work? Right from a master planning stage, we start our BIM models. What you're seeing here is the staging model for Liverpool Hospital, which I'm going to talk about in a little while. The colours obviously represent the different stages, but at this stage we can look at this building in an urban environment. That's really important for buildings like this that are campus type buildings, how they relate to their surroundings. We can do shadow studies from these models at this stage. We can take initial quantities off, we can take initial areas off, and therefore clients can get budget costs even from this very early stage. So it's still starting to build information into the model, and that's really what the models are about, being information rich. And that's capturing that knowledge now right from the start of the process. We work in a number of ways. We still have people who use butter paper. That's absolutely valid in the way that we work. We also use SketchUp, which is what you can see here for initial modelling of our buildings. You can see that same building, it then gets translated into ArchiCAD, and obviously a level of detail is now being started to add. And ultimately that becomes a visualisation which is used for submissions for DA, or obviously for clients, and to attract potential tenants. We have a number of methods of doing visualisations. This is a PPP bid for a hospital. Unfortunately we didn't win, but this is a very big building, $750 million development, and this was documented fully in 3D to quite a decent level with the FF&E included in about 6 months. We also use Artlantis. Artlantis is a great plugin for us. It does lots of what we call quick and dirty images. All our project teams are capable of producing these quick images to sell to clients what we're trying to do. Here you can see some examples of some DA documents that we've recently submitted, and I spoke earlier about how much more information we're putting into our models and the design decisions we're making earlier. To get this quality of documentation for a DA and for a client, we really need to be making those quite detailed design decisions much earlier. It's not about drawing lots of lines on an elevation until we think it looks good. It's really about making decisions about the components that we're using. You can also see in the left-hand image that we've modelled the urban terrain, and you can see the crossfall across this site. So it's pretty important for us to understand and to convey to council just how these buildings are fitting into a tight urban situation, in this case in North Sydney. So how do we physically work? And I'm sure many of you have seen this and would be familiar with the way that 3D modelling works. Essentially what we do is we model objects in 3D. We no longer draw lines. Lines have no intelligence in them. Modelled objects have lots of inherent intelligence in them. So we draw our model and effectively we cut a horizontal plan. That gives us a plan that people traditionally need, obviously, to build buildings and to set buildings out. We cut a section through that plan and automatically we get what we call a clean section. There is absolutely no line work in that section. The fills and everything you're seeing are automated from that initial model. We annotate that section. Again, the builder needs information about set out and specification of items, and we place what we call a detail marker, say at the end of the balustrade, and again we get an automated 2D, in this case, detail of the end of that balustrade. So when a change is made in that initial model of that staircase, all of these drawings are automatically updated because we've only drawn those objects once. We no longer draw a plan, open another sheet, draw a section, open another sheet, draw an elevation, and open many more sheets and draw details. We draw things once, and then we just cut and slice and dice our models to produce the information. We arrange it on sheets. We try to put 3D images on our sheets. We believe you get much better tender pricing if you include 3D images in your tender documents. The builder still needs to know how to build it, and that's what surrounds the 3D image. So we use ArchiCAD's scripting language, which is GDL, to produce what we call smart library parts, or parametric parts. What you're seeing here is the precast concrete library part that produced the schedule I showed earlier, and in the bottom right and centre you're seeing a library part for a piece of glazing, and on the top right is for a car park screen. So if we just talk a bit about what we script in, we can script any parameters into these parts that we want to then be able to schedule out. In the case of the glazing component here, we had a project that had somewhere around about 6.5 kilometres laid end to end of slab to slab glazing. This single dialog box controlled all of that glazing. So when you stretch it in plan, it knows automatically where to put the mullions in, and it wasn't a regular grid, but we can script in irregular grids as well. When you stretch it vertically, it knows that if it goes over a certain height, the mullion depth needs to change from 150 to 200. So we're really just writing rules into the computer, and the computer is really just obeying those rules. So in this case, when the tenant came on board and he wanted the mid-transom moved from 2100 above floor level to 2200 above floor level, we were able to open this dialog box, overwrite 2100 with 2200, click OK, and 53 drawings automatically updated. That's the power of parametrics, that's the power of BIM. Now, we still had to revision those drawings to be able to send them out, but again, that's something that we're currently working on to automate as well. What you see here is a combined model for Liverpool Hospital. There are essentially 5 discipline models here: FF&E, Interiors and Architecture, which are being done by Rice Daubney. MEP Services are being done by the DNC subcontractor Allstaff, and Structure is being done by SCP, the structural consultant. So all those models are combined together, and you can see how complex this image is, because hospitals obviously are very complex buildings. We can use that model for clash detection. Essentially, because everything's spatial in these models, everything understands where it sits pretty much exactly in the world. You can run this program and ask it to show you all the things called pipe and all the things called duct and where they physically inhabit the same space, and that's a clash. And this software will pick that up automatically, and we can then deal with those clashes. In this case, I think it says that we need to move the pipe up 25 millimetres. In retail, we can also do some fairly clever things in terms of the way that we produce images for our retail master plans. This is the leasing plan for our Orion development, which is in Queensland. It's a 6-star, Green Star retail centre. And what you're seeing here is not just a two-dimensional leasing plan, but you're seeing how each of the retail tenancies relates in the third dimension. Some are stacked on top of each other. As part of our process and part of our delivery, we have to produce lease outline drawings. They get attached to leases. They're pretty important documents. They need to be accurate. And because we're coordinating and modelling in 3D, we believe the accuracy is much better. And also we're sticking a 3D image on that lease outline drawing as well. So it's very clear to everyone what's included in that contract for that retail tenancy. In health's very much about modular rooms, and it's very much about standardised rooms. What we've done is we've sought to automate some of the ways that we work with within our health and research sector. What you see here is a number of different rooms. Each is coded separately, and those are New South Wales health codes for particular rooms. And what we've done is we went away and built somewhere around about 2,500 individual library objects so that we could automatically schedule them out of our models and improve our briefing process and automate some of our briefing process as well. So having scripted all those library parts, we can drop that F&E into our models. So we can produce room layout sheets and room data sheets. In this case, they're partly combined, and you can see an image there, a three-dimensional image of a room, and from that automated we get an RCP, a plan, and the elevations. In the top right-hand corner of the drawing, what you see there is all the equipment that is being automatically read and scheduled off of that 3D model. So if a piece of equipment is removed, it is removed from the list. We have automated line of heights. So if, for example, a paper towel dispenser is moved from 900 above floor level to 1200 above floor level, that model will automatically update, the elevations and everything will update, but importantly, the tag that relates to that item will automatically update in the elevation from 900 to 1200. So we're really trying to remove some of the human input into these processes and to automate them as much as possible, because they aren't the most exciting things that we do as architects, and therefore they are prone to error and mistake. We can also do object counts on our models. You can imagine in a project the size of Liverpool Hospital, which is in the not far off $300 million project for the main clinical services building. We can count the objects in that model, and in some cases there are hundreds of individual objects, and we can schedule those out for the builder. Traditionally, someone would be going around drawings and counting those objects by hand, and in 2010 that's really not good enough. We can also check our areas against briefed areas. Because we know the briefed area, and because it's scripted into our models, the model knows the actual area, and it can produce the sheet that you can see in the foreground, highlighting in red where we don't meet our brief, and we can go and fix up those issues. We can also apply finishes automatically, and what you can see in the drop-down menu on the bottom right-hand corner of the slide is all the finishes for this project in relation to these clinical rooms. They're scripted into our wall part, so our CAD operator is really just selecting the particular finish for that particular wall, and then it's automatically scheduled out to our finishes schedule. For us, this is all about managing our risk. Our industry is all about risk these days, particularly in a D&C environment. Obviously, we're getting great visualizations. These are live. I think it's important to stress that. Whilst this is a static image, we're very much able to take tablet PCs now into user group process, and we're able to take the users through their model in a live environment. When we change that environment based on their requests, we're able to go back and show them the updated model. So it's not just giving them a pretty picture of a room in a 3D model, it's actually a live model. What I'm going to talk about now is a recently completed project which is called the ARC in North Sydney, and its BIM objectives and what we've delivered in terms of BIM. So the ARC sits in North Sydney. It's on the fringe of North Sydney, just behind the Post Office on the Pacific Highway, and sits pretty much, as I say, on the fringe of the CBD. The actual development, roughly 2,500 square metre site area, 28,500 NLA, PCA A grade over 21 commercial floors. Now you can see from the image it's got a cranked facade, which again, when you're working in 3D, it's important that we were working in 3D, because there's a lot of difficulties in working with 2D with abnormally shaped facades. It's 6-star Green Star, and we believe the first high-rise building in Australia completed and handed over as a BIM with asset information. So a quick timeline for the ARC. We recognised the potential of this site in January 2006. Investor acquired the site in July, and at that point we convinced them to make this a fully BIM project. Having got our DA approval in 2007, TIS were appointed in 2008, and we completed the project in April 2010. So part of our advice was that TIS take on a BIM consultant, in this case CQR, and a chap called John Mitchell. And what John did was produce a model collaboration guide. So this really set out the parameters and protocols for exchange of models on the project, and it's really important that those things are set out early in the piece. We had a lot of new people to BIM on this project, and it was very, very important that they understood how we were going to collaborate. So the document runs through how to save files out, how we're exchanging, and all those protocols. And then very early on, John was starting to get some pretty interesting three-dimensional images, and he was using Celebri Model Checker to check the models and combine them. So again, very early stages. This is a model just post-DA, so again, early stages of the project. We're able to strip that model down, take the architecture off, we can take the structure out, and we can look at the services independently. What you're seeing here that's been modelled is the top plant room, basement plant room, and a typical high-rise and low-rise floor, although actually there are no typical floors in this building, interestingly. Traditionally, the way that we would coordinate this project is to take drawings like this, we'd stick them on a piece of glass with 2 fluorescent tubes underneath, a light table, and we'd try to coordinate in 3 dimensions. That's a really daft process in 2010. With what technology is capable of today, it really doesn't make sense to be doing that kind of stuff. This drawing is actually taken from a model, at this stage a fairly rudimentary model, but even at this stage we're able to cut a section through it. And to get some comfort, this is a tight building. We have a height plane on this building, at which we managed to sneak some extra floors under by crunching the floor to floors a little bit. So it's pretty important we understood what was in the ceiling void on this project. As I said earlier, you can start to get some rudimentary 3Ds. In the case, for example, of the bottom image, you're starting to see what are actually flexible ducts projecting through the ceiling. Obviously that's not going to happen in reality. The flexi duct will sit on top of the ceiling. But I think importantly, if you look at the column and the hole in the ceiling beside the column, this ceiling has been drawn on plan, on a two-dimensional plan. That column is cranked. The bottom of that column is what's being reflected in the cut on the ceiling. Now the ceiling's set out on the centre line of that column. If we hadn't picked that up in the third dimension, the ceiling would have been set out off-grid, which would not obviously have looked as good as setting it out on the centre of the column. So if you think about the way that we work as designers, we dream a lot, we conceive of things, and we all dream and conceive in 3D in our minds. Traditionally we would draw that in 2D. What we're actually doing though is virtually building it, and this is now the model, stripped down model for the services of the Arc. And then a builder goes away and he builds that in 3D. So if you think about that process, there's very much at the moment a missing link. We're going 3D, 2D, 3D, and what BIM does is fill that missing link, because we're actually virtually building the building. These are some snapshots from a 4D timeline for the Arc. TIS were running 4D models on the project. It assists with construction logistics, safety, where you need scaffold, when you can get cranes in and out on the site, all that kind of stuff that help them to efficiently program the building. In the top left image, you're starting to see the footings coming up and the start of the jump form. And you see a white band there that's actually some permanent shoring on the site next door. So from this model you can start to understand that if that shoring is up in the air, how are we going to do it? We're going to need some scaffold or some method of fixing that shoring. As the model progresses, you can see that the jump form is continually ahead of the structure, and in the third image the glazing's starting to be put on, and then that completes through the bottom series of images. So very useful information. You can link these models to programs through Primavera or Microsoft Project. You can adapt the program which adapts the model, or you can adapt the model which adapts the program. The other thing that BIM really seeks to do is capture knowledge. If you think again about the traditional process that we go through in procuring buildings, there are huge losses of knowledge between the different components. For example, we as designers very rarely are asked to get involved in the procurement stage other than delivering a set of drawings and specification. There's huge losses of knowledge and drops of knowledge in that process. What BIM's really seeking to do is capture that knowledge through the model and continue that knowledge. Now, from a handover to a client perspective, you can start to see that if that knowledge is captured, it's of huge value to the end client. And that's really why we have, in this case, WebBIM. This is a snapshot from the as-built model for the Arc. This now sits on Investor's server, and they're able to interrogate this model. You can see in this model some smart tags have been added. When you click on those smart tags, they take you out to WebBIM. And what this shows you then is that piece of equipment. That's an actual photo of the piece of equipment, and on the right hand side of that Explorer screenshot is all of the PDFs that relate to the O&M manuals, drawings, warranties, everything you need to know about that equipment. And included on the text on the left are its associated systems, who's responsible for installing it, etc., etc. So it's a capture of important knowledge for the client. Doesn't just relate to plant, architectural components such as the car park gates. Similarly, you can click on the hyperlinks and take you out to the website, and even down to things like exit signage as well. So it's quite a detailed asset management model. This is the interface, and you can see that it has a number of different registers. An asset register which lists all the individual assets in the building, discipline registers, so who's responsible for delivering the systems under the system register, and then the organisations involved in the project. Now you can interrogate this website and you can spit out any number of different reports, and here's just an example of some of those. From on the left, a 20-page report on all the assets in the building, to on the right some information about the internal cladding in the lift lobbies, which is zinc cladding. So all your information that you need as a building owner is there in terms of your warranties, maintenance, and valuable asset information. Here's one of the systems in the building, in this case domestic hot water, and you can see highlighted in red in the 3D image are some pumps. When you click on those, it takes you out to the website, and there you can see the O&M manual. You open the O&M manual in a PDF format, and there it spits it up for you in 20 or so different languages. Very valuable information. It's editable and updatable, so it's a living document now, or a living e-document for the client for the life of this building, and it's capturing huge amounts of knowledge in that process. So what have we learned from the ARC? BIM is not yet a perfect process. We shouldn't kid ourselves. These are the formative days, and we're working pretty much at the forefront of BIM today. The timing of the models is critical, very critical to process. You need models early. We need services models earlier. We weren't getting good services information in this case from consultants. It really came from subcontractor. We really need to change a little bit of the mindset. There's a bit of a mindset today about BIM that we had when 2D CAD was introduced, and that is people have a perception that because it's electronic, because it's a computer, it must be right. Unfortunately, we still have a weak link in the process of BIM, and that's us as people, because unfortunately we're not perfect. Using IFCs was problematic at times. Some of the file sizes were difficult for some of the subcontractors. This was their first time working in BIM, so they probably did need to upgrade some of their hardware. The time to create them, we were doing weekly issues of not just IFC models, but we were issuing IFC, DWG and PDF weekly. I think on reflection that was probably too much. There is still a bit of a lack of understanding of BIM, particularly in this case. The client, contractor and subcontractors weren't familiar with it. They all did a fantastic job. TEAS did a fantastic job, and their subcontractors, of upskilling themselves, and I think they would all say they're pretty well converted to BIM these days. The next project obviously is going to be much more successful and much easier process for everyone. And very importantly, the structure, naming conventions and other protocols for the model must be defined early. And I think again that's something that our industry is really going to have to grapple with in terms of some sort of standard. So what are some of the issues that face our industry? True interoperability and the lack of a standard. I just spoke about that. We really do need to collaborate as an industry and come up with a standard. We need to have naming conventions for parts. Is a door in my model called doors in someone else's model? If it is, they won't translate correctly. So we need to start defining some of these protocols, and someone in the industry needs to take up the mantle for this. Is there any additional liability? I get asked that question a lot. I don't believe at the moment. Once you start getting into web servers, I think there is potential for additional liability, and those are issues that need to be solved, as I mentioned earlier. From our perspective, we still deliver essentially what we were commissioned to deliver years ago, and that is we need to design and document a building sufficient for a builder to deliver it. The fact that we choose to do that in a BIM process is to our benefit, and in my view actually gives us less liability. Another question I'm frequently asked is about intellectual property. Again, if you're producing somewhere around about 2,500 unique library parts, some of which you can see in this model, then potentially there's some intellectual property that you're not going to be happy to give away too quickly. We technically don't need to give that away. If we're collaborating in other products, we're not necessarily giving that information away. We can also script that information so that it can't be opened in other pieces of software or on other people's servers. So these things can be got around. So I don't know that there's a real issue around IP at this stage of the game. I think cost is a barrier for some people, particularly in the current financial climate. We were fortunate when we switched to 3D and ultimately to BIM, in that we were already running ArchiCAD. We were just using it wrong. We were using it as a 2D drafting tool. So for some people there may be some cost in some licensing. You certainly need a gruntier machine to run 3D successfully, and if you're going to ask your staff to use the latest technology in terms of software, you need to give them the latest hardware as well. That's not expensive these days. We're running 64-bit 8GB RAM computers, and they're only really costing between $1,500 and $2,000 a piece. 4 or 5 years ago we were running 2 gig of RAM and they were costing $4,000 to $4,500. So technology prices are obviously coming down. I mentioned earlier about how we put a lot more information in our models earlier, and what this graph seeks to show is the white curve is a traditional process, and what you can see is that there's a really big effort of work in the construction documentation phase. That curve is shifting forward for us because we are making our decisions earlier. We're having to get good model outputs. But you can see that that makes sense when the cost of a design change is only going up through the project and your ability to impact on that cost is only going down. So you can see from the graph that it's much smarter that we're working much earlier, And what we really now need to do is start to look at contracts and the way that people are remunerated in our industry. We have one client who is a BIM client and professes to be a BIM client, and they pay us on a slightly different fee structure to the traditional structure to reflect the work we put in earlier. And I think that's where we're going to have to push as an industry. There is a lack of companies doing it. This is a structural model not produced by us, but I would have to say that probably on 90% of our projects we do produce the structural model, because as architects we need to show structure within our documents. We don't want to be doing that. We've been doing that for a number of years now. There are now a large number of consultants who are really getting stuck into BIM, which is terrific. It's terrific for the industry. But there still is a bit of a lack of companies doing it, which is holding things back a little bit for us, certainly. It has the potential, I think, to change some roles in our industry. Again, this is a screenshot from Liverpool Hospital. This is one of the plant rooms in the hospital. This model, all the MEP that you see in this model is being produced by D&C subcontractors. The consultants are not working in 3D on this project, and I think that's a bit of an issue. And I really think that if all consultants aren't starting to find a way that they can get involved with BIM, they're going to start to see their roles become less important in that process. So for us, BIM is changing the way that we do business and the way that we work, and we very firmly believe that it's a better way, and certainly the way that we're using ArchiCAD has been instrumental in the way that we move forward as a business. Thank you very much.